Welcome back, adventurers. Have you ever wondered what a mountain sheds besides tears? Well, get ready for an epic showdown between two of nature's most powerful movers and shakers, avalanches and lava flows. Today, we're diving deep into the world of these destructive yet strangely beautiful phenomena. Buckle up, because things are about to get hot and cold. We'll crack the code on what triggers these monstrous slides, unveil the hidden dangers that lurk beneath the snow and molten rock, and even explore some surprising ways these forces can actually be beneficial. So, whether you're a thrill seeker or just curious about the world around us, this video is guaranteed to erupt with fascinating facts. Number 1. Definition and formation. Avalanches occur as a rapid descent of snow, ice, and rocks down a slope, typically transpiring when a significant accumulation of snow or ice renders the slope unstable. Various triggers, including natural phenomena such as earthquakes or a heavy snowfall, along with human activities like explosions or skiing, can instigate avalanches. Contributing factors encompass steeper slopes, precarious snow layers, and severe weather conditions. Lava flows refer to the movement of molten rock from a volcano onto the surface of the Earth, originating as hot magma deep within the Earth. It ascends and erupts as lava. The characteristics of the lava flow vary based on factors such as viscosity, slope, and eruption style. The rate of lava flow is affected by its thickness, while the terrain dictates its direction. Additionally, the volume and direction of the lava flow is determined by the location of eruption vents. Number 2. Nature and types. Avalanches are a terrifying phenomenon, massive flows of snow, ice, and debris cascading down mountainsides. These fast-moving torrents can bury entire valleys, leaving destruction in their wake. Understanding the different types of avalanches can help us mitigate their risks. There are 3 main categories of avalanches, each with distinct characteristics. Loose snow avalanches. These are the most common type. Dry, powdery snow accumulates on a slope and detaches, triggering a fast-moving, tumbling flow. Think of a giant snowball rolling downhill, picking up more snow and debris along the way. Wet snow avalanches occur when warm temperatures, rain, or a combination of both, saturate the snowpack. These avalanches are denser and slower than loose snow avalanches, but can be incredibly destructive due to their weight and ability to travel long distances. Slab avalanches, the most dangerous type. A cohesive layer of snow detaches from a weak layer below, creating a rigid slab that slides down the slope. These avalanches can be incredibly powerful and travel at high speeds, reaching up to 200 miles per hour. Several factors can trigger an avalanche, including heavy snowfall, especially after a period of calm weather, can overload a slope. Warm temperatures can weaken the snowpack, making it more prone to avalanches. Earthquakes, explosions, or even a skier triggering a loose snow avalanche can disrupt the stability of the snowpack. If you live or recreate in avalanche-prone areas, it's crucial to be aware of the risks and take precautions. Here are some key points. Learn to recognize avalanche terrain and warning signs. Avalanche beacon, probe, and shovel are essential for locating and rescuing buried victims. Stay informed about current avalanche conditions before heading out. Lava flows are mesmerizing yet destructive displays of nature's power. They occur when molten rock, cold lava, erupts from a volcano and flows down its slopes. The resulting landscape can be transformed, leaving behind solidified rock formations. The nature of a lava flow depends on the composition of the lava. Basaltic lava, the most common type. This hot, fluid lava flows easily, creating broad, sheet-like flows that can travel long distances. Think of molten asphalt slowly spreading out. Andesitic lava, thicker and more viscous than basaltic lava. It forms shorter, blockier flows that solidify rough and jagged. Imagine chunky, slow-moving molasses. Rhyolitic lava, the most viscous type. It cools and hardens quickly, forming short, steep flows. Think of thick, slow-moving toothpaste oozing out of a tube. Lava flows can have a significant impact on the surrounding environment. They can destroy property and infrastructure like buildings, roads, and other structures can be engulfed by advancing lava flows. Lava flows can reshape entire landscapes, creating new volcanic features and burying existing ones. Lava flows can devastate plant and animal life in their path, but over time, new ecosystems can emerge on the cooled lava. While lava flows are a natural phenomenon, scientists can track volcanic activity and predict potential eruption zones. This allows for mitigation strategies, like diverting lava flows with channels or constructing barriers. Understanding the nature and types of avalanches and lava flows is crucial for those living in or near these hazardous zones. By respecting the power of nature and taking necessary precautions, we can minimize the risks associated with these awe-inspiring yet destructive forces. Number 3. Biggest and smallest avalanches and lava flows. Avalanches and lava flows come in a surprisingly wide range of sizes, with some giants that reshape landscapes and others that might go unnoticed. If we talk about biggest avalanches, the undisputed champion is the Little Ice Age mega avalanche that occurred around 12,500 years ago on Mount Shasta in California. This monstrous avalanche traveled over 80 kilometers and left a deposit over 300 meters thick in some areas. On the other hand, small avalanches can occur on any steep slope with loose snow. These might be just a few meters wide and travel only a short distance, but they can still be dangerous for skiers or snowboarders. In contrast, the record breaker for lava flows is likely the Deccan Traps in India. This wasn't a single flow, but a series of enormous eruptions over millions of years that covered over 500,000 square kilometers with lava. Small lava flows, called toe flows or pahoehoe breakouts, can erupt from the base of a volcano and travel just a few tens of meters. These can be slow-moving and often solidify into interesting ropey or blocky formations. There's a special type of avalanche called a lava flow avalanche. Imagine superheated, molten rock cascading down a slope like an avalanche. These occur when the steep sides of a volcano collapse, taking some of the lava flow with them. Number 4. Speed of avalanche and lava flow. Avalanches and lava flows are both powerful movements of material, but their speeds differ dramatically. Let's delve into the world of speedy avalanches and sluggish lava flows. When it comes to speed, avalanches are the clear winners. These fast-moving masses of snow, ice, and rock can reach incredible velocities, posing a serious threat to life and property. The speed of an avalanche depends on several factors, including the type of avalanche. Powder snow avalanches. These are the fastest, reaching speeds of 100 to 300 kilometers per hour. Imagine a speeding car. Wet avalanches. Heavier and denser. They travel slower, typically at 20 to 80 kilometers per hour. Debris avalanches. A mix of rock, soil, and snow. They can reach speeds exceeding 300 kilometers per hour due to their sheer mass. Factors affecting speed: steeper slopes, lighter and drier snow, and larger avalanche size all contribute to higher speeds. In stark contrast to avalanches, lava flows are slow and methodical. The speed of a lava flow depends on the viscosity, thickness of the lava. Basaltic lava. This is the most common type and is very fluid. It can flow at speeds of 0.5 to 10 kilometers per hour, similar to a slow walk. Andesitic lava. Thicker and more viscous. It moves at a glacial pace of 0.1 to 0.5 kilometers per hour. Factors that affects the speed, the steepness of the slope and the rate of lava eruption also influence speed. Steeper slopes and higher eruption rates can lead to faster flows. Number 5. Trigger mechanisms. Avalanches, characterized by swift downhill movement of snow, ice, and debris, can result from a variety of factors, often in combination. Here are several key mechanisms. 1. Rapid accumulation of snow can overload slopes, particularly following light snowfall, that creates a slippery base layer. 2. Intense precipitation can increase water weight in the snowpack, heightening instability. 3. Strong winds can redistribute snow, forming drifts that add weight to specific areas and provoke avalanches. 4. Warmer temperatures or rain can melt the snowpack at its base, reducing friction and elevating the risk of avalanche. 5. Earthquakes can shake slopes, disrupting delicate equilibrium and prompting avalanches. 6. Skiers, snowboarders, and snowmobilers can inadvertently trigger avalanches by adding weight to stress slopes. Lava flows, resulting from volcanic eruptions, are driven by the ejection of molten rock from a volcano. The specific cause varies depending on the eruption type. 1. Effusive eruptions. These gentler eruptions entail the gradual release of basaltic lava, which is fluid and thin. The trigger is primarily the accumulation of pressure within the volcano's chamber, leading to the gradual extrusion of lava. 2. Explosive eruptions. These more violent eruptions involve the discharge of gas, ash, and fragmented rock tephra, in addition to lava. The trigger may stem from the buildup of gas pressure within the magma chamber, or from the interaction of water with hot magma, resulting in sudden steam expansion. Number 6. Destructive power and temperature. Avalanches can be triggered by a variety of factors, including heavy snowfall, rapid warming, and vibrations from earthquakes. They can travel at speeds exceeding 200 miles per hour, and they can be large enough to bury entire forests, buildings, and infrastructure. When an avalanche occurs, the moving snow can suffocate victims and cause widespread destruction. Lava flows are streams of molten rock that erupt from volcanoes. Lava flows can reach temperatures of over 1,200 degrees Celsius, and they can burn and melt everything in their path. As lava flows cool and solidify, they can divert rivers and reshape landscapes. It is important to be aware of the risks of avalanches and lava flows, especially if you live in an area that is prone to these hazards. There are a number of things that you can do to protect yourself from avalanches and lava flows, such as being aware of the risks in your area, having a plan in place for evacuation, and following warnings from local authorities. Number 7. Composition, mobility, and frequency. Avalanches and lava flows both move due to gravity, but differ in what they're made of, how they move, and how often they happen. Avalanches are mainly snow and ice, sometimes with rocks and trees, and they move fast, especially in extreme cases. They can happen in mountainous areas during winter, depending on snow and weather, but big ones are rare. Lava flows are molten rock from volcanoes, with different minerals based on the eruption. They move slowly, usually no faster than walking speed, and their frequency depends on volcano activity, which can vary greatly between frequent eruptions and centuries of dormancy. Number 8. Detection and monitoring. Living near mountains offers stunning views, but also risks like avalanches and lava flows. Thankfully, science has ways to detect and monitor these dangers, keeping us safe. For avalanches, we use seismic monitoring, Doppler radar, weather stations, and remote sensing to spot them early. And for lava flows, we rely on ground deformation, seismic monitoring, satellite data, and visual observation. These methods help us evacuate people, predict behavior, assess risks, and improve our understanding, making our communities safer and more informed. Number 9. Hazards and risks. Both avalanches and lava flows are powerful natural forces, but they bring different dangers. Firstly, avalanches. They can crush buildings, forests, and communities with walls of snow, ice, and rock. Triggers include heavy snowfall, temperature changes, earthquakes, and vibrations. They move fast, giving little time to escape. They can cause floods and suffocation. In contrast, lava flows. They destroy everything in their path, with molten rock at temperatures up to 2,000 degrees Celsius. They damage buildings, infrastructure, and towns. They move slower than avalanches, sometimes at walking speed. They release toxic fumes like sulfur dioxide. They cover large areas, changing landscapes and blocking waterways. In summary, both are dangerous, but avalanches cause sudden widespread destruction, while lava flows threaten with extreme heat and toxic fumes. Number 10. Historical events. Avalanches and lava flows, both stunning demonstrations of nature's might, have caused some of history's worst disasters. If we talk about avalanches, in 1887 Switzerland, The Plomlamen avalanche, triggered by heavy snowfall, buried a hotel and killed over 100 people. In 1970 Peru, the Yungay avalanche, a massive ice and rock slide from an earthquake, destroyed Yungay, claiming over 20,000 lives. In 2014 Washington State, USA, the Oso mudslide, akin to an avalanche, buried a neighborhood, resulting in 43 fatalities. On the other hand, lava flows. In 79 AD Mount Vesuvius, Italy, Vesuvius's eruption covered Pompeii and Herculaneum in ash and lava, preserving a snapshot of ancient life. In 1881 Krakatoa, Indonesia, Krakatoa's eruption and ensuing tsunamis killed over 36,000 as lava domes collapsed. In 1980 Mount St. Helens, USA, Mount St. Helens's blast and ash cloud, though causing fewer deaths 57, had significant economic and environmental impacts. These are just a few examples of how avalanches and lava flows have reshaped landscapes and human history. Number 11. Geographical distribution. Avalanches mainly happen in mountainous regions where there's a lot of snow, especially in places with frequent snowfall or rapid temperature changes. The most avalanche-prone areas are typically in major mountain ranges such as the Himalayas, Andes, Alps, Rockies, and Sierra Nevada. Lava flows typically come from volcanoes, so they're found in volcanic zones, often along tectonic plate boundaries. These boundaries create a ring of fire around the Pacific Ocean, including places like Indonesia, Japan, the west coast of North America, and the Andes Mountains. Some volcanoes, like those in Hawaii and Iceland, form over mantle plumes away from plate boundaries. Number 12. Cultural significance. Avalanches and lava flows, though destructive, are culturally significant worldwide. Avalanches are seen as both destructive and renewing, featuring in myths like the Norse god Jormungandr. Similarly, lava flows, associated with Hawaiian goddess Pele, symbolize creation and transformation, inspiring respect for nature and resilience in affected cultures. And finally, number 13. Future trends and climate change. Climate change affects avalanches and lava flows differently. Warmer temperatures could cause more avalanches due to unstable snow, while wetter winters may increase the risk of destructive wet avalanches. Glacial retreat might decrease snow sources for avalanches, but increase water-induced risks in some areas. For lava flows, changing precipitation patterns could alter eruption styles, and glacier melting might trigger destructive mudflows during volcanic eruptions near lakes. Technology can aid in prediction and preparation, like avalanche barriers and volcanic hazard maps. Adapting and mitigating these risks is crucial to minimize their impact on communities and ecosystems. So guys, that was a wild ride, wasn't it? From the bone-chilling power of avalanches to the fiery fury of lava flows, we've explored the awesome and sometimes terrifying forces that shape our planet. Remember, even though these events can be destructive, they're also a crucial part of the Earth's natural cycle. If you enjoyed this volcanic eruption of knowledge, don't forget to like, comment, share and subscribe, and hit that notification bell for more earth-shattering content.